Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com.
Hi, everybody, and welcome to the ARC Digital Transformation Podcast. I am Larry O'Brien of ARC Advisory Group. I have here with me today Grant Vanderbrake and Arnold Offner of Phoenix Contact. Good afternoon, guys.
Good afternoon, Larry.
Good afternoon.
How are you doing today?
Good.
Doing well.
Today we're going to talk about Ethernet APL, and that stands for Advanced Physical Layer. And what we're doing with Ethernet APL, it's a new technology. This essentially brings Ethernet down to the field device level, right, for end users in the process industries. So we want to talk about what is Ethernet APL, and then we want to talk about the cybersecurity features and challenges of APL. So I'd like to start with a brief description of what Ethernet APL is and what it does, and maybe Arnold, you could take the lead on that. But before we get into that, I'd like each of you just to introduce yourselves and tell us what you do at Phoenix Contact and the Ethernet APL organization.
Yes.
All right.
Go ahead, Arnold.
So, Larry, Phoenix Contact was right there from the very beginning with the APL project. Phoenix Contact, of course, developed and then designed the APL switch technology here in our Harrisburg, USA facility. Essentially, it is a two-wire system that allows us to replace existing 4 to 20 milliamp type loops. And that's what APL is for us. It's actually the transition to the digital world of using 10 megabits of communication via a standard we know as the IEEE 802.3CG, the single pair Ethernet. It's a 10 megabit T1L, in other words, 1,000 meters. And what APL is nothing more than a physical layer, so you can put any kind of Ethernet protocol on top of it. And essentially, that's what the APL stands for. It's the advanced physical layer that allows us to go into what we would call the Zone 1 applications in the European market of IECX and ATEX, but it can also be used in a Class 1 Div 1 type application here in the North American market.
Thank you for that description, Arnold. I have to say, we at ARC think this is a really useful technology. I did some work with Fieldbus in another life, and we used to kick around this idea, of replacing the physical layer, of H1 Fieldbus with Ethernet. It was kind of like, why not? This is the technology that's out there right now. I think it makes a lot of sense. But Grant, I'm going to turn this over to you. I mean, and as I talk to end users about Ethernet APL out there in the process industries and so forth, there are some concerns about, and questions, right? Because we're ostensibly bringing Ethernet down to a device layer now. And that raises cybersecurity questions. So what I want to ask you is, does Ethernet APL support any, cybersecurity features? Does it bring cybersecurity technologies from other, standards organizations and so forth? What does Ethernet APL have for, cybersecurity built into it right now?
Yeah, and it's an excellent question, and it's one that there aren't really some upfront answers to that, because when you look at the APL standard, like Arnold had mentioned, it's very focused in on the connectivity and the power and being sure that we can work in intrinsically safe zones. But you do have the underlying Ethernet technology. So you do have things like IP addresses, MAC addresses, all of those lower layers on the OSI for the communication. But what that also allows is standard cybersecurity features that are built into things like managed switches or firewalls, where you can utilize those types of protection mechanisms with sensors now. So before, it's all serial bus, and with serial bus, you were limited on the visibility you had past the gateway or past the DCS system or PLC, whatever you're using to communicate to the field bus. So you were limited in what you could see, diagnostic functions based on what type of field bus you're using. With Ethernet, you now have status and connectivity feedback all the way out to the sensor. And you also have things like the IP address and MAC address, which you can use for filter options. So like in standard switches, there's protocols like 802.1x for network-based authentication, where you can take a MAC address of an end device and you can essentially store it in an authentication server, and you authenticate that MAC address. So if you plug in a sensor and you don't have that sensor's MAC on your allowed list of devices, it's not allowed to connect physically onto the network. So that's one thing that you can utilize for security reasons with standard Ethernet. Firewalls are also a big one, because you can limit the scope of communications from higher level in the network. So if you have something from the enterprise side, or if you have some sort of engineering workstation or something in your standard server network, you could put a firewall in between. You can limit the access you have from the upstream systems. So that's pretty much what is afforded to you with Ethernet is extended security capabilities, along with the connectivity, along with the redundancy, along with all the other things that come along with Ethernet. So there are a lot of advantages now to moving towards an Ethernet-based architecture. And I'm really curious to see from the end device manufacturer, the sensor manufacturers, what can also be built in, because switches do what switches do. APL is a physical layer technology for connectivity, but this affords the device manufacturers a lot more options to do security in the device too. So that's really an area I'm excited to see get expanded.
Yeah, and I think it's an area that we haven't explored a lot in the world of process automation, is actually cybersecurity at the device level. I know a lot of people have spoken about it. A lot of companies have tried to come out with solutions, but it's been kind of an intractable problem, I think, for a bunch of reasons, right? Both on the user side and the supplier side, the technology hasn't really been there. The users haven't really thought much about it, I don't think. They have a lot of other cybersecurity concerns. Should users worry about possible Ethernet vulnerabilities, with Ethernet APL at the device level? What would you say to users that say, geez, I'm really worried about a DDoS attack on my field device, or something like that? Are these true notions, true concerns, or do users have to worry about this, or what do you have to say about that?
I would say that with any new technology, there's always cybersecurity considerations that you have to take into account. So you are adding Ethernet onto a serial bus that didn't have Ethernet. And with that comes along with network access and the ability to communicate to the end device directly through the network. Like I said before, previously, unless you had a gateway, you could not communicate on the serial bus from an Ethernet network. So that kind of at least air gapped, quote unquote, the serial bus from the rest of the control network that had standard Ethernet. Now you're putting Ethernet down to the field device. So you do have to consider that. But I would say that along with the technology that you've now introduced into the serial bus, you get the benefits. There are some concerns, but you also just get the capabilities that I mentioned previously. You do have the ability to secure that communications, because with Ethernet, there's 20 years, 30 years of firewall technology, end device authentication. You can use and layer in all of the existing security mechanisms that we have in place to then secure the communications to the end device. So you can put a firewall in that will prevent a denial of service attack. You could rate limit certain communications through switches. We have that capability of storm control. You can do things like passive monitoring. So a big thing with a lot of other industries is to be able to monitor the traffic inbound and outbound on the network, laterally and vertically, to see if there's any anomalies. You now have that capability. You were blind to that serial bus, but now you have Ethernet, so you can copy those packets and frames and analyze them for any sort of anomalous traffic. So like I said, you do introduce those vulnerabilities, but you also introduce the mechanisms to address those vulnerabilities as well, because we've been using Ethernet in other industries and other places for a long time. So there's a lot of things that have already been developed that you can utilize now where you couldn't before with a standard serial bus.
Yeah, I personally think it provides more opportunities than risks. It's a great way to extend your cybersecurity strategy down to the device level, which, as you said, has previously pretty much been blind to us, right? With 4 to 20 milliamp analog technology.
Yep.
Very hard to tell what's actually going on. Even if you're using like a HART communication protocol or something like that, right? There's not a lot of actual network diagnostics going on, with a technology like HART and so forth. Yeah. So, I think this is a great way to kind of expand things, and those technologies will continue to exist, right? It's just that Ethernet APL will be the physical layer for those technologies. And I think that's another thing that a lot of end users kind of get confused about is like, well, this Ethernet APL isn't going to replace, all your existing field communication protocols. It's going to be a physical layer option, right, for those protocols. Am I correct in stating that? Yeah.
Yeah, absolutely. I think one of the things that gets lost with the addition of Ethernet is you can multiplex on the network. It's not limited to one 4 to 20 amp loop, one serial bus communication protocol. Like Ethernet is a multiplexed communication standard. So like you can put other communications on those lines out to the sensor now. And you can separate those logically with VLANs. That's another thing that I'm curious to see with the end device manufacturer. The switches support VLANing, which means you can separate logically the ports or the protocols, if the end device supports it, into whatever limitations, scope on the network that you want. I mean, I run into this with the power industries as well. The end devices support VLANing, which means you can separate out the different message schemes into different VLANs, which have different scopes and access. So you do have the ability to run several different types of communications now to the sensor. It could be web. I've seen that some of the new sensors that are coming out that support APL have web interfaces where for configuration. Didn't have that before, that you could access through the network. That's a management interface. You can put that into a different VLAN, separate that communication. Some probably have a diagnostics interface. Some will have a protocol interface like a Modbus TCP and Profinet. So you do have the ability to communicate several different ways to the same device now, and you can separate that communications using standard Ethernet technologies now.
So basically what you're saying is if I have multiple types of devices existing on multiple device level networks, if those share the Ethernet APL physical layer, that essentially allows me to have a holistic view of all my devices on all the networks for security purposes through Ethernet APL.
Absolutely.
Yeah, that's pretty powerful stuff. Mm-hmm. So I know this wasn't kind of on our list of, questions that we talked about at the beginning, but are we seeing implementation of this right now? Are there users actually out there implementing this and doing cybersecurity on this? I know this is really early days, so.
Yeah, I'll let Arnold hop in with some specific customer examples maybe, but from a device support perspective, our switch that is the Ethernet APL enabled switch does have a standard managed switch operating system and has the same managed switch capabilities. So we do have the things that like port-based network access control, password protection, the ability to run encryption on the interfaces. Those are things that come with a standard managed switch. It's a question I've heard comes up with customers, but like you said, technology is really early in its adoption phase. So it's more of implementing the technology period than securing it necessarily. But that's just been my experience. So.
Yeah, I'd say that for projects out there, probably the best known one right now is one that is being done in China by the company BASF. And what they've actually been looking at, of course, is making sure that even though the devices themselves are not yet ready, they've implemented this idea of a proxy capability. In other words, they could use a field bus technology like Profibus PA and then later go to a Profinet-based solution, because, and I think that's something else to think about, we're migrating from a technology that has been around for about 20, 25 years, the field bus technology. And in the case of Profibus PA, it never really took off. I think the same could be said too for Foundation Field Bus. It was competing against the 4 to 20 milliamp loop and HART. And in the field bus space, you would say that the speed of 31 kilobits or 31 kilohertz is probably, it's an upgrade to go 300 times faster. But what you're also now able to do is, once you do have the APL device, is you're able to get all that additional information that Grant's referring to. In other words, the diagnostics. You can now have information reside on the device. You can now check version control without having to wait long periods of time like you might with HART. And so all of that data is now available, and so your field instrument does actually become a supplier of information to different, shall we say, departments, to different people within a plant, whether they be operations, whether they be in maintenance, whether they are just making sure that everything is still running correctly. All these different departments now are in a position to get that data from the field instrument.
Yeah, that's a great point, Arnold. As I said, as a field bus person going way back, way more than 20, 25 years, I think. I still remember the field bus wars. Foundation Field Bus was a great technology, but it never really did take off en masse, right? Like HART did and so forth. And certainly the same can be said for Profibus PA. And yeah. I think this is a great way to tie everything together into a common environment and actually get instant access to all this information that's just been kind of sitting in these devices. And one of the things, we spent years at ARC telling users they need to get more out of their devices, but I just think we kind of made it too hard for them in a lot of ways. And I think this is the thing that kind of bursts open the dam, and makes it so much easier for everybody to get access to all that information, But the only thing that concerns me is, now that we have this, we're going to have this massive outflow of information. I could just see the computing requirements at the device level, especially, if you're going to implement, firewalls and security technology. We're going to need more get more computing power. We're going to need a bigger boat, I guess, is probably, the right thing to say here. But I think, ultimately this is going to create some great opportunities, and we're going to see, new trends in the data. And I think it's going to be great for end users, ultimately.
Larry, I would say that the interesting thing too about APL is that it's really currently a migration from what we know as those field bus field devices. So we've been able to up their speed by 300 times, as I said. We're still competing, I think, with the applications that run on HART, which, APL is 10,000 times faster. And so I would say that the first APL devices that you're going to see are probably the ones that currently are available in either a HART or a Profibus PA or a Foundation Field Bus application. And coming back to your point, APL then supplements the original or the existing, I'd say, the discrete I/O, those devices that don't really need an IP address because they've got a wealth of information on board. So I think what Ethernet has really done is help to actually open up the access to the device, because now with APL, we can talk about actually taking data to the cloud. And unfortunately, when we take it to the cloud, we then have to throw on the protection that cybersecurity requirements, afford us or require of us. If you think about things like the CRA, the Cyber Resiliency Act now in Europe, yes. That essentially is also what now has to be considered as we, take this technology forward. Because the switch is essentially going to be put into, I'd say, critical infrastructure. It's going to be used on pipelines. It's going to be used in chemical plants, oil and gas facilities. It's going to probably be used in a number of applications where, we didn't think it was possible. But hey, APL has now become that solution, and it gives us that open access to data as a manufacturer, as an end user. But it also, unfortunately, then, if not correctly protected, like Grant points out, allows us then to make sure that it stays secure and that people don't get to tamper with that kind of infrastructure because it's on the internet or because it's on a network.
Mm-hmm. Right. Yeah, good point. This has been a great discussion. I'm glad you mentioned CRA, by the way, because not enough American manufacturers really know about the Cyber Resilience Act, which, of course, as you know, is an EU-sponsored initiative. largely around the security of products that are manufactured, by suppliers and so forth. So you think there's a way that Ethernet APL will actually make it easier for companies to get CRA compliance?
I mean, it could be. So there's a little bit of distinction to make with CRA. So CRA is a supplier requirement. So that's for vendors producing products. There's also NIS2, which is the end user based standard that is in the European Union. So if you're an end entity, if you're a petroleum producer, if you're a process customer, then you would follow NIS2, which would be the regulation for the actual end user. The vendors have to follow CRA. So that's requirements for us to produce secure devices. So from a end user perspective, I do believe that Ethernet APL does provide you more capabilities to actually secure the networks that you have in communication. And you can go back through history and look at a lot of attacks on industrial systems that used protocol gateways as a way to get access and communications or disrupt communications. So with APL, you remove the need for protocol gateways, you remove the need for heart gateways, you remove the need for gateways, which is basically a possible insecure device that then has visibility to the downstream bus. So doing that, you do remove one of the main vulnerability points. You do introduce Ethernet, which has got standard, vulnerabilities to it as well. But once again, you have all those capabilities in place.
Oh, so that's a great point. Yeah, there are so many of those gateways out there. I wouldn't know where to begin to count. Yeah, hard gateways and everything else. And that's a great point. They've always kind of been this kind of proprietary hardware widget thing that's kind of unique to the automation business, in my experience, because we've had these, both proprietary and open technologies, pop up in our industry and that have required all these gateways. So anything you can do to eliminate a gateway is a good thing. That's kind of a fundamental rule I learned a long time ago. But what I was thinking with CRA was it might actually make it easier for suppliers to make secure products, with Ethernet APL and to prove that they are secure, I wasn't trying to say that CRA was irrelevant, but it could actually help the vendors make, more secure products. And of course, on the end user side for implementation, it can help the end users achieve NIS2, certification and conform to those regulatory requirements, because obviously it's making it a lot easier for you to get visibility into the cybersecurity at the device level and so forth, and to protect those devices in those areas of the plant.
Absolutely.
This has been a great discussion, guys. Are there any resources that we can recommend to the end users that might want to find out more about Ethernet APL technology? Where should they go?
So the 4 SDOs, I'll name them: the ODVA, responsible for Ethernet IP; the PI International, so Profinet, Profibus International, responsible for Profinet, and of course in the past Profibus PA. The Fieldcom Group, responsible, of course, now for a lot of what is going to be done as regards the physical layer testing of APL product. And then, of course, the OPC Foundation with OPCUA. They are all the 4 standards development organizations, or the SDOs, involved in Ethernet APL. So they all carry a page relating to their Ethernet APL activities. That would be my first suggestion of where to go looking. And then, of course, to go looking at those 12 companies that all got together, almost 6 years ago now, to actually start developing this, shall we say, and avoid, as you said earlier, the field bus war, because essentially all we were looking for was looking to develop a physical layer that then would have an Ethernet protocol put on top. So that would be my suggestion. Those are the folks to go looking out for, the SDOs, and then, of course, the 12 companies involved. Including
that's
Phoenix
great.
Contact.
And if they, I'm sorry, what?
I say including Phoenix Contact, if that.
Including Phoenix Contact, yes. And I was going to say, if our listeners want to get in touch with Phoenix Contact and maybe you guys, how would they do that? Should we look on LinkedIn?
Yeah, we're both on LinkedIn.
Okay, good.
Yeah, we're both
Very
on
good.
LinkedIn.
So,
we do have several channels as Phoenix Contact on LinkedIn as well. So I'd recommend going to LinkedIn first.
All right, thank you, guys. I think this has been a great discussion. glad to get the more information out there about Ethernet APL and the security implications of that, rather. Again, we at ARC think this is a great technology. We just want people to be aware of it. So please, if you're an end user out there, please check out Ethernet APL with your, favorite communication protocol organization, whether that's OPC UA or Profibus or HART or FieldComm Group, etc. And feel free to get in touch with Phoenix Contact as well. And thank you, Arnold, and thank you, Grant, for joining us today on the ARC Digital Transformation Podcast.
Thank you, Larry.
Thank you, Larry.